Okay, today we'll be learning about bone healing. So whenever I talk about the term bone healing, one term comes into mind, that is bone fracture. So as in general, if I discuss what is fracture, there is something which is broken. There is a fracture in a smooth area, or a continuous something is broken into two or more than two parts. That is called as fracture. Similarly, if the fracture occurs in bone, we will call it a bone fracture, right? So now there are two or three terms which I'll be discussing here, so that it will make you go through the topic even better. You will understand the topic in a better way. If I use the term osteo, what do you understand? Osteo means we are talking something about the bone, right? And there are two different types of cells which we'll be discussing in the process of bone healing and fractures. One is osteoclast, other is osteoblast, and the next is osteocyte, right? There are three different terms: osteoblast, osteoclast, and osteocyte. So one thing we have already learned, that osteo means bone. So here is a clear classification that we are talking about the human bone, osteo, right? Now there are three different terms: clast, blast, and cyte. Okay, so clast, if I say, clast means the breaking or the destruction mechanism. Okay, so the clast cells are basically responsible for breaking the bone or destructing the osteocells, right? So osteoclasts are breaking or removing the bone cells, right? Basically, its function is to remove the debris after the bone fracture has taken place. Osteoblast cells, whenever I use blast, that means a cell which is immature, right? So this is an immature cell, and when I refer to the term osteoblast, that means the immature cells have started to accumulate into a certain area, which will definitely become mature bone cells. So this is the initialization of the development of a new bone after the debris of the broken bone is removed, right? So we'll follow the stepwise process. I just want you to be aware of what these terms mean. So osteoclast, clast means destruction, blast means immature cell, and cyte means mature cell. What kind of a mature cell is this? Osteomature. Osteo means bones. A mature bone cell, immature bone cell, and a destructive bone cell, right? So I just wanted you to be aware of these terms. So whenever I use them in the mechanism later on, we can get through the entire meaning of the mechanism or of the process, right? So yes, bone healing is basically after the bone fracture. So what kind of bone fractures are there? There are three different kind of bone fractures. One is single, other is compound, and the last one is pathological. Okay, so there are three different kinds of bone fractures. Either the bone fracture is single, when the bone is not protruding through the skin, that kind of a bone fracture is called a single bone fracture. When I say compound bone fracture, that means the bone is protruding through the skin. So there is some kind of a severe damage here, or more than one bone is broken, or maybe a bone is broken into two to three different parts. Pathological fracture is usually taking place when a bone is broken due to pathological condition. That is, due to some kind of a disease, the bones are weakened and have become fragile, and that leads to the breaking of the bone. So there are three different kinds of fracture, right? This is a diagram or a labeling of how a bone looks like, and then I'll tell you where is this process of healing taking place, right? So there are two different types of healing. If I classify healing, healing is either primary healing or secondary healing, right? Primary healing is taking place in case of less than 2% of strain. So if the bone is broken and there is less than 2% of strain, in that case primary healing takes place. Here the two bones directly join to each other and there is no intermediate stages which are required. The bones are uniform, forming a single bone after the healing process takes place. But in case of secondary healing, which is the major criteria, most of the bones go through the process of secondary healing. Here, the strain is between 2 to 10%. So this involves a multiple set of stages after which the bone healing is completed, and we'll be learning about the secondary healing here, right? So there are a lot of intermediate stages in case of secondary healing, right? In general, when you are asked about what are the stages or intermediate stages of healing, we'll be mostly discussing about the secondary healing because there a lot of intermediate stages are explained. So secondary healing of a bone. What is healing here? A bone is being healed, right? So there are 5 stages in which I'm just writing these all bold and I'll remove them off. We'll be discussing about individual mechanisms stepwise. The first one is destruction and hematoma formation, right? The first one is destruction. What destruction? Tissue is being destructed, tissue destruction and hematoma formation. The second is inflammation. The third one involved soft callus formation. Next is hard callus formation. And the last one is the remodeling. Okay. So this is between 4 to 12 weeks. This is 2 to 3 weeks of the process. Okay. So now I'll also explain you. This is how a bone looks like. Okay. First of all, this is the periosteum. This is the bone cortex. This is again the periosteum. This is the medullary canal. If I say suppose this is the area in which the bone is broken, this is the fracture site, say for example. So in this area, the destruction and hematoma has initially begun. So whenever there is an impact, deep impact supposedly on this side and the bone breaks, wherever I say there is 2 to 10% of the strain, which leads to the initiation of secondary healing, what mechanisms or what step it goes through? Initially at this site, at exactly this point, the destruction has happened. Okay, so what has been destructed here? The muscles, the cartilage, the osteocells, the blood capillaries, all of them have broken, and this leads to hematoma formation, right? Hematoma formation leads to inflammation. This exactly triggers the second step, which is inflammation. In inflammation, there is an acute inflammation reaction. An acute inflammation reaction is triggered. Okay, and exactly at this site, surrounding cells, macrophages, we must have learned about the inflammatory cells, macrophages, PDGF, and transformation growth factor, platelet derived growth factor, and macrophages. I'll just write down all these terms here so it becomes easy. This is transforming or transformation growth factor. PDGF stands for platelet derived growth factor. This is actually TGF beta. So TGF, PDGF and macrophages, they start due to the initiation of the acute inflammation reaction, all of them, they start to accumulate at the site of damage or at the site of hematoma formation. Here the inflammation begins. Okay, so after the inflammation begins, what has happened here now? I'm just clearing this off, and let's clear the stages which are done. So tissue destruction we have understood, hematoma formation we have understood, inflammation we have understood. So now there is soft callus formation. So in case of soft callus formation, the mesenchymal stem cells. So again we are talking about this exact site. I'm just redrawing it here, a smaller diagram. So there is inflammation after the hematoma. So this site has actually been destructed. So meanwhile, the mesenchymal stem cells, they start to enter the site of damage. So when they start to enter, these mesenchymal stem cells are derived from surrounding areas. From surrounding what? The surrounding periosteum, medullary canal, and the surrounding muscles. So mesenchymal stem cells from periosteum, medullary canal and muscles, they start to accumulate at the site of destruction, and now they start differentiation. So they begin the process of differentiation. Here I am talking about the soft callus formation. So in the soft callus formation, the site which is damaged, which was actually now inflamed, has led to the formation of a new bone. So how is a new bone being formed? The mesenchymal stem cells, they start to accumulate from the surrounding periosteum, medullary canal and muscles, and the soft callus formation begins. How the soft callus formation begins? The mesenchymal stem cells, they differentiate into what? I'm clearing this off so it will become easier. The mesenchymal stem cells, they differentiate into three different cells: fibroblast, chondroblasts, and osteoblasts. Again, the same terms. I hope you remember. Blast means we are talking about the immature cell. And what are we talking about? These different types of cells. So they will mature into some different cell which will be leading to the formation of maybe cartilage, maybe bone, maybe fibrous tissue. So mesenchymal stem cells, they differentiate into fibroblast, chondroblast, osteoblast. All three of them are immature cell, but they mature into fibrous tissues, cartilages, and bone cells. Bone cells, what are the mature bone cells? Osteocytes. I hope you remember. Site is the term for a mature cell. So they mature into fibrous tissues, cartilages, and osteocytes, or the bone cells. So this is actually happening at the site of damage. So new bone cells have now started to form there. This is entirely the process of soft callus formation, which begins at 2 to 3 weeks from the damage of bone. And in the case of soft bone formation, the sticky ends of bone have started to begin. So a sticky bone end have started to form at the site of damage. This is some kind of a repair which is happening, a serious repair. So now what will happen? I'm just clearing this off. We are beginning on the fourth stage, that is the formation of hard callus. So this, what is hard? What is soft callus initially? Soft callus was comprising of immature bone. And what is this immature bone? This was made up of fibroblast, chondroblast, and osteoblast, right? And what was all them they forming? It was leading to the formation of fibrous tissue. It was leading to the formation of cartilage. It was leading to the formation of the osteocyte. So this is the immature bone. This is actually the soft callus. It has sticky ends, and this process begins from 2 to 3 weeks from the site of damage. Now the next step starts to form. It is called as the formation of hard callus. Hard callus formation begins. How the hard callus formation begins? Hard callus formation begins from 4 to 12 weeks. It is by two steps, two different processes. If I say osteofication, that means osteofication means formation of bone. Either it is through endochondral ossification process or intramembranous. Intramembranous or endochondral. So hard callus formation begins when the soft callus has now begun to form. The soft callus has now differentiated through the mechanism of endochondral ossification process or intramembranous ossification process, and finally it leads to the entry of calcium in the matrix, right? So if this is the site, so now the calcium has started to enter in this area, and we know when calcium starts to enter, what process is beginning now? Mineralization of the bone has already begun. So the mineralization of bone has begun. Now the bone has started to become dense. Okay, and still, even if the process of the bone formation has begun, still there is cell debris. Okay, which has to be removed. So there is a constant process of osteoclast and osteoblast happening here. Still the bone cells are being removed and the new bone cells are being formed. Now there is a question that when already the cell debris has been removed, now what is the use of clast here? Then why the bone cells have to be destructed when they are already being formed? So the bone, if this is the bone structure and this is the empty site, so the bone forms in this way. The entire area is filled with bone. So this extra bone has to be removed to form a uniform bone after the fracture, right? The new bone formed is actually in this of the same design or the same size as it was in the case of prior to the fracture. So this kind of bone has to be formed, so the extra bone cells have to be removed, and who's taking care of that? The osteoclast cells. New bone cells are being formed, and bones in the extra area, they have to be removed by the osteoclast mechanism, right? So now finally, after this osteoclast and blast activity, finally we have a healed bone which is dense, and this is how the bone healing process takes place in case of secondary healing. So there's a brief intro about the primary healing. In case of primary healing, the bone formation takes place by directly connection of both the bones, because there is less than 2% of strain there and the bones are directly formed. There is some kind of a gap which is filled in case of narrow or wider damage, and there the new bone cells are being directly formed. There are no intermediate stages involved in case of primary healing. But in case of secondary healing, again I'm summarizing, there are 5 different stages which are involved. The first stage involves the destruction of the tissues and hematoma formation. So tissue destruction is taking place and then hematoma formation is taking place. In the second case, inflammation is being triggered at the site of the damage, and macrophages and tissues surrounding, like the factors I discussed about, the platelet factor, the transforming factor, TGF beta, PTGF, macrophages, they start to accumulate at the site of rupture. In the third stage, the soft callus formation begins, where the site of damage leads to accumulation of mesenchymal stem cells from the surrounding periosteum, from the muscles, and from the medullary canal. That medullary, in that case, the mesenchymal cells, they start to differentiate and they start forming fibroblast, and they start forming fibroblast, chondroblast, and then also the osteoblast. The osteoclast activity still is taking place because of the extra bone has to be removed. The fibroblast and chondroblast, they lead to the formation of mature fiber cells, that is the fibrous tissue and the cartilages. We know why cartilages are required for the bone. And then ultimately a soft callus formation, sticky ends of the bone have started. Sticky ends, like the two edges in which the rupture has happened. Then the hard callus formation begins. In case of hard callus formation, the bone has now started to form go through the process of mineralization, where calcium accumulation is happening. The osteofication has started to happen by either intermembranous process or endochondral mechanism. After the osteofication process, the bone is finally dense and still the clast and blast activity functions, which ultimately leads to the form of a healed bone. So these are the 5 stages. I hope you understood both the primary and secondary healing. The secondary healing involves 5 different stages. And why is all this happening? After a fracture, which I classified, there are 3 different kinds of fracture. So I hope you understood this topic. We'll be taking forward the skeletal system in few more topics. You can pin down, you can comment on the message on the videos that what more topics you like me to cover in the case of skeletal system, and then we'll move on to different systems, then the drugs involved for healing these conditions. We'll be also discussing about the pharmacological action of drugs. We'll also be discussing about their mechanism of actions, the disorders. So anything you want me to cover, you can drop that in the video comment section. Thank you. Like, share and subscribe. Thank you. Let's learn medicine by Dr. Nikita.